All right, so now we're going to go ahead and look at this one, and we're going to go ahead and try to graph these. The easiest way to graph these, a lot of times, we're going to take that first equation, 4x minus 6y equals 12, and we're going to set x equal to 0. So if I set x equal to 0, I get 0 minus 6y, or just minus 6y, equals 12. I'm going to divide both sides by negative 6. And I get y equals negative 2. So there's one point for that one. Then I'm going to set y equal to 0. When I set y equal to 0, I get 4x minus 0 equals 12. Divide both sides by 4, and x equals 3. So now I have 2 points, 0, negative 2 from the first one, and 3, 0 from the second one. So what I would do at that point is I would graph that. So I get 0, negative 2, which is down here. And I get 3, 0, which is here. So I have one line that looks just like that. Then I'm going to try the other equation. So I have negative 2x plus 3y equals negative 6. I'm going to do the same thing. I'm going to set x equal to 0. So I plug in a 0 for this term, so that disappears. So I really have 3y equals negative 6, so y equals negative 2, because I divide both sides by 3. So y equals negative 2. I then set y equal to 0, so I have negative 2x equals negative 6, divide both sides by negative 2, and I get, so this time now y equals 0, by the way, and now I get x equals negative 3. Well, notice that get positive 3. So I have 0, negative 2, and 3, 0, which are the exact same points that I have there. So that tells me they are the same line. Therefore, they are consistent, but they are dependent. Dependent means they're the same line. So that's what I have, and that's what it's asking for. So determine the number of solutions. Since they are the same line, we know that they have an infinite number of solutions. That's just a shortcut for writing solutions, and that's that problem. Okay, y equals 4x plus 2, y equals negative 2x plus 4. This one's a little easier to graph just by looking at it, because we can see that the slope equals 4 and the intercept equals 2. So I have the intercept at 2, slope is 4, which means I go up 4, 1, 2, 3, 4, and always to the right, 1. So I have these 2 points for my first equation. I want to show you why this is kind of a mess here, but I'll show you that in a minute. This one here, I know that m equals negative 2, my slope equals negative 4. So 1, 2, 3, 4. And my slope is negative 2, which means I go down 2 and over 1, and they cross. Notice that they cross like right about here, somewhere around there. Okay, so now trying to determine what that means in this particular case, that's a little bit more difficult to try to comprehend or figure out. So I know, just because I've graphed them, is that they actually cross right at this point, which is this point right here, at negative 1, which is here, and negative 2, which is here. So that means that that's the crossing point. So whenever they're asking find the solution, this whole point here would be the solution. Now notice that my graph is kind of off, because it looks like 1 should be here and 2 should be here. So this is why graphing isn't the cleanest. And I am going to go to that on the next problem and show you how to check that. Okay, you do have a check that you have to do. And then we're going to go to DESMOS, and we're going to plug these in to see how to do it. So this is the way that you can actually go through and do everything, is that you can go over to DESMOS.com. We're going to turn these off. Someone asked me, why do I turn them off instead of just writing the whole new equation, or just replacing them with the equations? Because if I need to go back and check any answers, I've still got these typed in. So I don't have to go back and look at that one more time. So we have 2y equals 5 plus x. 2y equals 5 plus x. Okay. And 3x minus 6y. 3x minus 6y equals negative 15. I'm pretty sure that's what it says. One more time. So 2y equals 5 plus x, 3x minus 6y equals negative 15. If you look at this, and we're going to kind of come out a little bit, notice that it looks like it's the same line. Now, I don't know that for 100%, so I'm going to turn this off. Oh, yep, it is. There's the red line, and there is the blue line. So notice the blue line just covers it. So now if we go back and look at the problem after graphing it on here, we know that they are the same line, just like the example I gave you above. So they have an infinite number of solutions. Okay, and we know that the system is consistent, but it's dependent because they're the same line. That's the information that we need to know. We are done with this section.